Assalamu alaikum warahmatullahi wabarakatuh and very good morning. In our previous lecture session we were discussing about the equilibrium of rigid bodies. We have started with an introduction to rigid bodies. We were discussing about the moments and also we have seen finally about the support reactions. According to Newton's third law of motion, every action has equal reactions. Okay, so whenever you are restricted to move, you will try to resist it by creating a force. So if a body is restricted to move in one direction, it creates a reaction. So reaction may be a force or it may be a moment. When you are not allowed to move, when you are not allowed to translate, when you are not allowed to move in x and y direction or to and fro motion, you will have a force, reactive force. When you are not allowed to rotate, then there will be a reactive moment or reactive torque. Okay. So these two reactions you will have in the rigid bodies. And we have seen the list of reactions for different categories of supports. So today we will see how to find out these reactions. We know there are reactions and we have seen what are the types of reactions we will have for the particular type of constraint. If it is not allowed to move in x direction, we will have a force in x direction. If no movement in y direction, force in y direction, like that. So we have seen different supports and their corresponding reactions. Either it may be a force or moment. Today we will see how to solve the reaction, how to find out this reaction, the magnitude and direction of the reaction forces and reaction moments. Okay. So for that we have to apply the equilibrium condition. Okay. We know a body will be in equilibrium if your sigma f equals to 0 and sigma m equals to 0. Generally for applying your equilibrium condition, it is better to consider the body as a rigid one. Okay. So we have converted already all the forces acting on the body as a single force, all the moment as a single couple or single moment, then also into a single resultant force. So if a force or moment to be in equilibrium, your sigma f should be equal to 0 and your sigma m should be equal to 0. The resultant forces and resultant moment, net force acting on the system and the net moment in the system should be equal to 0. So why we consider it as a rigid? It won't deform. So the alteration of force, line of action of force or axis of the moment is not happen when you consider it as a rigid body. Okay, that is why we consider the bodies as rigid when you apply the equilibrium conditions. So deformation is very small. Direction of the applied force is not altered and the moment terms also remain same for analysis. Okay, that is why we consider this as a rigid body. Now we will see one example. We know what are the equations. We have applied it in our coplanar force system also. In particles, equilibrium particles, we have applied sigma f. In addition to sigma f, now we have sigma m. Okay, because the moment will exist only in a rigid body. The particles will not have a moment. Particle no dimension. So particles, all the forces are concurrent. We consider a particle will have the force system acting on it as concurrent. So there is no moment, there is no chance for moment in a particle. So moment will exist only in the rigid bodies or bodies. Okay. So we will apply now the forces and moment, equilibrium of forces and moments to find out the support reactions of the given beam. So this beam is hinged at both the ends. Both ends are hinged. Okay. So hinged means how many reactions we will have? It is shown all the forces acting on it. 100 Newton vertically downward force is acting and 200 Newton at end B and 600 Newton inclined force is acting at point between A and D. So A, B, D is our beam. It is supported at point A and point B. The support is a hinged support. If it is a hinged support, what type of reaction we will have? There is no, it can freely rotate. Okay, hinged means, so it cannot be allowed to move in x direction or it cannot be allowed to move in y direction. So you will have two force systems. Force along x direction, force along y direction. You will have AX and AY. Similarly, Bx and By. And in order to find out the support reactions, we will consider the forces and their net sigma F value and also the moment. Okay, so how to find out the reactions we will see now. First, in order to resolve for the forces, we have to find out Bx. For finding Bx, we consider sigma Fx. Sigma Fx values. We add all the forces acting along x direction. So we resolve this inclined force into horizontal vertical force. This angle is 45. We can resolve it into two forces, vertical force and horizontal force. Okay, and this is vertical force, this is also a vertical force. The only horizontal force exists is 600 cos 45. So we get Bx as 600 cos 45 Newton, which is 424 Newton. Whereas in order to find the Ay, you take moment about B. So we take moment about B of all the forces. So moment about B means we have to consider the force and its perpendicular distance. So Ay times the total length of the beam is 4 plus 3, 7. Okay? So Ay times 7 meter. And you have to consider the sign convention also. Say for example, in most of our problems, the anti-clockwise rotation is taken as positive. Okay, clockwise is negative. So if you say Ay from B, so what is the direction of rotation? Clockwise. Ay and its moment is taken from point B. So it rotates like this. Ay is acting in this upward direction. B, the distance of your Ay from B, the vertical distance is 7 meters. So your moment arm is rotating in clockwise direction. That is why we have at the end here you have minus sign. Okay. So if you take moment of 600 sin 45 force, that is anti-clockwise, so positive. So 600 sin 45 times 5 meters, 100 Newton times 2 meters, and 200 Newton is passing through B. So its moment is 0. The distance of moment on B is 0. So 200 Newton and By will not have any moment when you take moment about B. Okay. So only the three forces Ay, 600 sin 45 and 100 Newton, they will create moment. So we got moment equation about B, from which we can find out the unknown Ay. Similarly, in order to find out By, either you can take moment about A. You can take moment of all the forces about A, or otherwise you can sum up all the vertical forces. Find out sigma Fy. There are two methods. You can find out sigma Fy also by applying that sigma Fy equal to 0 equation. We got By. Okay. So we got all the unknown support reactions by taking sigma F equation and sigma M equations. Okay, any doubt? So in order to find the support reactions, we are using the equilibrium equation. Sigma F equals to 0 and sigma M equals to 0. So I can take down any doubt you can ask. It's a flat surface and it is not fixed to the support. Okay, so this end it will not allow the beam to move in y direction. But it can slide, there is no bolts here. Okay, here we have a bolt. So this bolt will fix your beam on the ground, so it will not allow to move. It will not allow you to move in x or y direction. That is why we have two forces. Here no bolt is there, only a flat surface on the ground. Okay, on the fixed support. So that's why it can slide in y direction, but it cannot move in. It can slide in x direction, it cannot move in y direction. So that is why we have only Ay. Sigma Fx. So only we consider which forces are acting. In sigma Fx, we consider all the forces acting in x direction. So no force in y direction, no force at point A. So we did not take them. touch மட்டும் ரெண்டு போட்டு லோட் அப்ளை பண்ணல போல்ட் பண்ணல எந்தெந்த டைரக்ஷன்ல மூவ் பண்ண முடியாதோ அந்த டைரக்ஷன்ல உங்களுக்கு ரியாக்டிவ் ஃபோர்ஸ் இருக்கும். லைட் பண்ண முடியாது ரியாக்டிவ் ஃபோர்ஸ் இருக்கும். ரொட்டேட் பண்ண முடியலன்னா ரியாக்டிவ் மொமெண்ட்ஸ் இருக்கும். ஓகே. சோ இதுல வந்து ரொட்டேட் பண்ணலாம் ஹிண்டட் ஜாயின்ட்னால. அதனால அந்த பாயிண்ட் A ல மொமெண்ட்ஸ் கிடையாது. பாயிண்ட் B லயும் மொமெண்ட் கிடையாது. பட் பாயிண்ட் B வந்து சர்ஃபேஸோட போல்ட் பண்ணிருக்கு. ரெண்டு எண்ட்லயும் போல்ட் உடைய டாட் தெரியுது. பாயிண்ட் A ல ஜஸ்ட் ஃபிட் பண்ணிருக்காங்க. போல்ட் பண்ணல. அதனால you can even slide in x direction. Cannot move in y direction. And the flange கீழ இருக்க flange the surface just touch பண்ணி வச்சிருக்காங்க. ரெண்டும் போயிட்டு it is not bolted. It is not bolted, so if the force is applied, if it is trying to move in x direction, it can be moved. It can be moved in x direction, but it cannot move in y direction because of the flat surface and the ground is in contact. It cannot move in y direction. So only if AY is there in point A, but point B, since it is fixed, AY is there, BY is the reaction. Two reactions. Point A la one reaction, point B la two reaction. So first sigma affects all the horizontal forces. All the horizontal forces are the two na 600 cos 45 BX. But அதே क्वेश्चन கவர்மெண்ட் வராத அதே மாடல்ல வரும். ஓகே. கிட்டத்தட்ட அதே மாடல் தான். அதே அதே மாதிரி கன்ஃபார்ம் பண்ணீங்கன்னா இந்த கான்செப்ட் தரவா இருந்துச்சுன்னா நீங்க எல்லாரும் பண்ணலாம். நீ மனப்பாடம் பண்ணிட்டு வந்து here both are simply supported beams. Okay, this beam we call it as simply supported. It just supports, okay, and it's not allowing your beam to move in y direction only. Move along by y axis. Okay, no movement is allowed in y direction at point A as well as point D. The beam is loaded with what is this? UDL, uniformly distributed load. Okay, up to point B only, part of your beam. Then another load is there. This load we call it as point load. Okay, concentrated load or point load. In the first problem, all the loads are point loads only, or concentrated loads. Here you have UDL also, uniformly distributed load, and a point load. So you have two types of loads acting on your beam. So first, you have to convert this UDL into a single point load. So how will you convert? 20 times 3. The area of the rectangle you can say. 20 times 3. Okay. So that will be the magnitude of the load, and where it will be acting at the middle of AB. At the middle of portion AB. Okay. 1.5 meters. So you have to convert this into a point load. Now you have to find out the support reactions. So kilonewtons per meter. It's kilonewtons per meter actually. Kilonewtons per meter, and you have to convert it into point load. After getting converted into point load, you have to show the reactions. So two reactions you will have, two vertical reactions. It is not allowed to move in y direction only. So AY and BY you will have. Okay. So after considering all the forces, now find out the unknowns. You have to find out the unknowns either by using sigma F equation or by using sigma M equation, or both. Okay, that is the procedure. Okay, I will solve it on the board. And I want no talking. So first, also. Okay. So from point A to point B, UDL. From B to D, you have point load, UDL and point load. This is 20 kilonewton per meter for the length of 3 meters. This 1 meter. 1 meter and 1 meter. Okay. So first step, you convert UDL into point load. You have two reactions for the given beam. You have AY. This is DY. Two reactions will be there. AY, DY. So this load, we have to convert into point load whose magnitude is 20 times the length, 20 kilonewton per meter times 3 meter, 60 kilonewton. It will be acting at 1.5 meters. Okay, there is another load here, 50 kilonewton, which is 1 meters from D. Okay, so first step. This is called free body diagram. Okay, we have just taken the beam. We have shown all the reactions. So, okay, all the forces acting on it, reactions as well as actions. So these are the two actions: 660 kilonewton and 50 kilonewton forces applied are the action forces, and the reactions are AY and DY. So this is the free body diagram of the beam. So after drawing the free body diagram, we can find out the unknown reactions. Say I am taking moment of all the forces about A. Taking moment of all the forces about A. Okay. So that means you have to consider the force and its perpendicular distance from A. So 660 kilonewton into 1.5, and what is the direction? Say I take anti-clockwise as positive. That's it. So this will be minus 60 into 1.5. Minus 50 into what is the distance? 4 meters. 50 into 4 plus dy into 5. dy into 5 equals to 0. This equals to 0. This is equilibrium equation. Moment equilibrium equation. Okay. So your dy will be equals to 60 times, how much is 90 plus 200 divided by 5. How much? 185 or 58 kilonewton. Okay. So this is dy. Only dy you got. Now you have to find out ay. For finding ay, you can follow the same procedure. You can take moment about d. Instead of taking moment about a, you can take moment about d, sigma mt. Or the other procedure is you can consider sigma fy. Sigma fy equals to 0. So consider all the vertical forces equal to, say upward force are negative and downward force is positive. I take the sign convention. Sorry, this is correct? Anyway, you can take anyway. The downward force is positive, so downward force positive, upward force negative. You consider the sign convention and add up. Okay. So this will be 60 kilonewton plus 50 minus 58. 68 kilonewton. All the vertical forces are added. Okay. 78. Huh? 52. I am very weak in mathematics. So 52 kilonewton. So this is our reaction dy. Reaction A. AY will be. So either use moment equation or force equation. I am not using moment equation. I am using force equation to find AY. Okay. So first, always first use moment equation to get one unknown. Then for getting the second unknown, you can use the moment about the other point, or you can consider force equation. Okay. You can take moment about the other point like sigma md. Moment of all the forces about point D, or you can just consider sigma Fy. Sigma Fy will be easier. You need not multiply it by the moment arm, and the calculation will be simpler. Okay? Simply supported beam. Okay, so you have to know that even if it is having roller at point B, it is simply supported beam only. Okay, roller is there at point B, no roller at point A, but there is a pointed tip. It allows movement in y direction, x direction. Roller, actually, you say roller is the practical. Problem. Here we will have the same kind of beam, a point load. Okay, so we have a beam, a UDL and point load. 50 kilonewton point load is acting at the midpoint. 50 kilonewton force is acting at the midpoint. UDL 5 kilonewton per meter at the portion BC. Okay. So here the support is different. You have a simply supported point A and hinged supported point C. Okay. So point C will have two reactions. Point A will have only one reaction. Point A will have only one reaction. A moment is applied at point A. Applied moment is there. It is not reactive moment. It is active moment. Action. Okay. 80 kilonewton meter moment is applied here, and one point load and UDL. So you have to first convert the UDL into point load, then draw the free body diagram. After the free body diagram, find out the support reactions by taking moments and forces, sigma F and sigma M. Try that problem. Try it on your board. Moment, that is the moment. Applied moment. You have an applied moment, one applied point load and one UDL. The point A is simply supported or roller regardless, so you cannot allow it to move in y direction. It can freely move in x direction. So only one reaction at point A. Point B hinged. So no movement, no translation in x as well as y direction. So two reactions are there. Two reactions. Hinged two reactions will go. Freely, simply supported one reaction. first step on the UTL convert பண்ணுது. Next step free body diagram. Third step take moment. Fourth step take sigma f. 4 steps are there. Okay. Support reaction to be there. Support reaction. ரெண்டு சப்போர்ட்ல தான் சப்போர்ட் reaction இருக்கும். A லையும் பாயிண்ட் C லையும் AY CY. ஓகே. This is the given beam, line diagram of the beam. Okay. So first we convert UDL into a point load. UDL, the magnitude of UDL is 5 kN per meter. It is over the length of 5 meters. So 5 times 5, 25 kN will be acting at the midpoint of portion BC. Okay. So B is here at the midpoint, C is here, A is here. So we will have 25 kN acting at. So this is your UDL. UDL is now converted into a point load. 5 kN meter is the force distributed over the length of 5 meters. So 5 into 5, 25. After that, this is the point load you have already. You already have a 50 kN point load. Apart from this, there is a moment. 80 kN meter moment is there. Okay. Now point A is simply supported. A roller is there, so you will have only one reaction acting vertically like this. So you represent this as AY. One support reaction. Similarly, point C, it has got a hinged support. There is only rotation. It can rotate. The beam can rotate like this, hinged. Okay. It cannot translate in y direction as well as x direction. So you have two reactions. CX, CY. CX and CY. Okay, two reactions. Now, after finding after drawing the free body diagram and showing all the forces, in order to find CX, we first use sigma fx equation. Sigma fx equals to 0. There is only one Cx. Okay. So sigma fx, can we have any fx here? There is no horizontal force at the moment. So sigma fx is 0. So you will say your Cx is 0. Cx is 0. Okay. As per the given applied system, your Cx is 0. Now you take moment of all the points about say point A. Moment of all the forces about point A. Okay. So you have 80 kN meter already. That 80 kN meter is in clockwise direction. Okay. So I take anti-clockwise as positive. I take the sign convention anti-clockwise as positive. Minus 80 kN meter. Then minus 15 times 5. Then minus 25 times 7.5 equals to 0. There is another plus CY times 10 equals 0. So your CY will be 80 plus 75 plus, how much is this? 187.5 divided by 10. This will be your C1. Okay, since suppose your value is negative, you assume that Cy is acting upward. Okay, suppose your value is negative, your assumption is to be considered as wrong. So it should be, suppose if you get negative value here, then you say Cy is acting downwards, opposite to what we have assumed. Since here it is positive, the assumption is correct. Okay, so after finding Cy, you have to consider sigma Fy equation. Sigma Fy and find out Ay. So I take downward as positive. Okay, so minus Ay plus 15 plus 25 plus minus Cy. So find out Ay. Find out Ay. So first we see that Cx is 0 because there is no horizontal existing force, action force or reaction force. So the net force acting on the system should be 0. So Cx is 0. Then take moment of all the forces about A to find out Cy. You can take moment of all the forces about C also to find Ay first. Okay, I have taken moment of all the forces about A to find out Cy. After finding Cy, consider sigma Fy equation to find Ay. This is the 3 steps generally we apply. If there is any horizontal reaction force, you consider sigma Fx. If no horizontal reaction force, directly go for taking moment about any one end point. Okay, any one end point to find out the reaction at the other end. Vertical reaction at the other end. Then use sigma Fy equation to find the other unknown reaction. Generally assume that beam is equivalent to reaction on the point of